Okay, so in this video, I'm going to be looking at U-Substitution, but with definite integral questions. So first things first, we have to still find the U. In this case, the best bet for the U is going to be x to the fifth plus 1, because that's what's under the radical. Typically, the U is going to be under the radical, or raised to the power of something, or just inside something else. So U is equal to x to the fifth power plus 1. du, which is the derivative of U with respect to x, is 5x to the fourth power dx. Now we can do the replacing. We can replace this 5x to the fourth power dx with du, and we can replace this x to the fifth power plus 1 with u. So I just went through this really quickly because this is kind of review if you watched my previous videos. So now what we do is we have to rewrite. But before I rewrite, I cannot use this 1 and this negative 1 as my bounds of integration. That's important to remember. Since I'm rewriting this in terms of u, I have to rewrite, or I have to find new bounds of integration. And the bounds of integration is just going to be 1 to the fifth power plus 1, which is equal to u, and negative 1 to the fifth power plus 1, which is equal to u. Those are the upper and the lower bounds of integration when we rewrite it in terms of u. So all we're going to be literally doing is using this equation right here to find our new bounds of integration. So that's just u equals 1 to the fifth power plus 1. This is the upper bound. So upper bound, which is 2. And then the lower bound is u equals negative 1 to the fifth power plus 1. This is our lower bound, which is 0. So what we can do now is we can rewrite it. So this is just going to become the upper bound is 2, the lower bound is 0. And now we can write the u's. So it's just going to become the u to the 1/2 power, which is the square root of u, it's equivalent, du. Now we can use the reverse power rule to make this u to the 3/2 power over 3/2 evaluated at 2 and 0. And since we rewrote this u, we can just literally plug this 2 in. So this is going to be 2 to the 3/2 power over 3/2, and also plug in the 0. And that's just going to be minus 0, since 0 to the 3/2 power is 0 over 3/2 still 0. So we don't need to even write that. So what is this going to be equal to? This is just 2 to the 3/2 power times 2 by 3, which is, so 2 to the 2/3 power, or sorry, 3/2 power, 3/2 power is equal to 2 to the 1/2, sorry, times 2. So that's just going to become 2 to the 1/2 times 2 over 3, which is just the square root of 2 times 4 over 3, which is just equal to 4 times the square root of 2 over 3. And this is our answer. Now, we could have done this a little bit differently as well, without changing the lower and the upper bound of integration. We could have just left that the same. So that's just going to be 1 and negative 1. And then this is going to be u to the 1/2 power du. And then we'd still have u to the 3/2 over 3/2. But we cannot evaluate this at 2 and 0 just yet. We have to rewrite this in terms of x. So it's going to be x to the fifth power plus 1 raised to the 3/2 over 3/2. Now we can evaluate this at 1 and negative 1, since we have those bounds of integration. So that's what we're going to have. And so when we do this, we're going to still be left with 4 square root 2 times square root 2 over 3, which is equivalent to this. So if you don't know how I just did this last step here, because I didn't show my work, I literally just plugged in this 1, got me 2 to the 3/2 power over 3/2, which is just what I got here, right over here. Yeah, that's right here. It's kind of messy looking. Let me rewrite this. So 3/2 I got over here, and then if I do negative 1, plug it in, that's going to give me 0 to the power of 3/2, 0 over 3/2. That's still 0, so I didn't need to rewrite it. And when I solve, I still get 4 times the square root of 2 over 3, which is equivalent to this. And let me do that in a different color, just so it looks more colorful. So I hope you found this video helpful.